get into this law of syllogism, which is the 2-3, I owe you guys this one last definition. A biconditional statement. Biconditional statements are ones you're going to see a lot because they have the words if and only if in them. You will see them with the good old if and only if. Biconditional means it's correct in both the regular form and its converse.
And the by to.
So let's see, real good, easy example. If an angle measures 90 degrees, then it's a right angle. We okay with that one? We all agree on that, right? Yeah. If an angle measures 90 degrees, bless you. If an angle measures 90 degrees, then it is a right angle. That would be your generic statement. P implies Q. If I say the converse of it, if an angle is a right angle, then it measures 90 degrees. Is that true or false?
True.
So when your conditional statement and the converse are both true, if they're both true, you can then say it as what we call an if and only if statement. And like that, so it'll look like this. And bless you, an angle measures 90 degrees if and only if. In other words, we don't like to write out all that if and only if because that's too many words. Remember what we used?
No.
If.
Oh, okay.
If. That that just stands for if and only if. There's no reason. A lot of times in math, we shorthand stuff. We use symbols. We use acronyms, things like that. We use letters to show stuff. Later on, we start talking like side, angle, side. We just use letters for all this stuff. If and only if is just an if. That's it. That's all it means. All right. An angle measures 90 degrees if and only if it is a right angle. That's it. That's what a biconditional statement does. You use that a lot of times with definitions. Okay? That's all it is. Bless you. So that's why I figured we'd wait to do this one into today.
You say an angle equals 90 degrees if and only if.
Correct. And an angle is a right angle if and only if it measures 90 degrees.
What?
That's all it is. That if and only if means that the conditional and the converse means they're both true. That's all it is. It means you can say it both ways. That's why I would say it's two biconditional, two conditions that it works. That's all. There's really not much to it. Most definitions you'll see have if and only if. A triangle is a right triangle if and only if there's a right angle. Pythagorean theorem, a squared plus b squared equals c squared if and only if the sum of the squares of the legs of the triangle equal the square of the hypotenuse. But it's things like that. Right? So, on to the next little definition. We call the law of syllogism. Otherwise known as the transitive property. This is really, really difficult. I'm lying. I don't. This is really tough. So, let's see. If, you know what? Would you mind coming up here? Would you mind coming up here? This, oh, I think this works. I don't have to. You're taller than me, right?
Yeah.
It's the hair, it's the hair, alright, so cool. No, I think yeah, it's the hair.
Just tell someone else.
Alright. He's taller than me. I'm taller than her, therefore, done.
But not put together.
That's the law of syllogism.
Right?
So it's
Wait,
like
what?
1, 2, and 3.
Wait, I'm completely confused.
Okay, here, let's turn around so Whiskey can see. Alright. Alright, ready, Whiskey?
No, I was messing with you.
No, really?
It's a troll. It's a troll.
Then what?
Alright, it's basically this. That's all, that's what the law, it sounds very, very weird. The law of syllogism. We actually call this the transitive property in and we'll talk about these properties more tomorrow. But this law of syllogism is used a lot of times to come up with conclusions. For example, if A equals B and B equals C, then what can I say?
Then A equals C.
Done. That's this law of syllogism. There is no reason to go into the entire depths of the word of all of it. If you can remember that Mr. Williams is taller than me and I'm taller than Ms. Isham, he's taller than her, done. A equals B, B equals C, therefore A equals C. Another thing that you're always going to see with these is this diagonal property. You will usually see something on a diagonal across from one another. When that happens, it's going to be a dead ringer that you're going to use what's called the transitive property or the law of syllogism. Okay? Let me show you an example in terms of words. Let's see, where was it? So where's the one I had?
I did not want it.
The word.
I didn't say it, announce it. I did not want to.
Oh,
I didn't go with this.
no.
Did you go last week? No. I thought you did. I'm so concerned.
I moved down a little bit. What are we doing?
Close that tab, that's why.
And you guys was trying to go to the public.
Don't write this out, but I want to show you what it looks like in terms of words before we get into.
So none of us were.
If you wear school colors, then you have school spirit. If you have school spirit, the team feels great. Therefore, if you wear school colors, the team will feel great. Notice what happens. It's a cheesy, silly example. It's very cheesy. Notice that this is here, and this is here. Those two are diagonal from one another. You finished with it in the first part, you started with it in the second. And then notice what happens with the third statement. Those two basically kind of just drop down. That's all it is. It's the same idea as A equals B, B equals C. These two are the same, therefore A equals C. That's all it is. That's all this means.
That's diagonal right there.
Yes, sir.
That is.
No, I just wanted you to see how it's very, very easy once you start to read it, because you've seen this probably before without realizing it. It's that when you finish with one statement and you start with the same thing, they kind of negate each other out and they just put them all together. That's all it
School
is.
conference, not all the time.
I know, I'm just saying, the idea of this statement here and here are repeated across from one another, that's why we can just say that those two work. Right?
I think I'm completely false.
It doesn't matter, all I'm saying is just how the
Diagonal.
flow of it works, that's all.
Yeah.
Okay. The other one we have is what's called, that, law of detachment. Okay. Again, I don't want to write out long-winded words. Law of detachment doesn't flow as cleanly as syllogism does. Law of detachment is extremely choppy. If you can think of it in terms of choppiness versus how syllogism seem to be very smooth, A equals B, B equals C, A equals C, that kind of thing, it just flows itself through, it's repeated through. Law of detachment is kind of not like that. Law of detachment is like this. The if it is Sunday, oops, you go to church, the farmer's market. Okay. You're still starting with an if-then idea. Exactly. It's Sunday. What do you say? Done. See how it's choppy?
It's because we went from having a complex sentence structure with different clauses to simple sentences, which is choppy.
It's very choppy. It's very choppy.
For example, it's Sunday, you want to have something that's not.
No.
It's Sunday. Oh, I'm sorry, this should have been
Should
great.
be clear, like, it is Sunday,
So it's two different.
Yeah. It's very, that's what we're saying. It's, what I want you to think of is detachment is just very choppy, okay? It's the idea that you can look at a string of thought, and the technical way that they say it, you assume your hypothesis is true. In our first statement, the hypothesis to conclusion, hypothesis, if it's Sunday, conclusion, you go to the farmer's market. I say it's Sunday, therefore, you went to the farmer's market. Yeah, pretty much it. Pretty much it. It's like I said, it's a very choppy idea as opposed to I am taller than you, you are taller than somebody else, therefore I'm taller than that person. That's it. I'm older than you, you're older than she is, I'm older than she is. Done. Well, I'm sure there are, just not in this room.
What?
That's about all that is. We can make this more difficult if you'd like.
Can we go back to numbers now?
Yeah. It's the whole idea of logic. We show you.
Yo, Mr. Murphy,
Yes, sir.
when we start doing math?
We will.
The very next slide.
The other part that I wanted to look at today was postulates, this whole thing about postulates and diagrams. And this is actually going to be really, really easy to work with. Yeah, I told you, it's not going to take much to go through both of these today. What I'd like to do is I'd like you guys to take your Chromebooks and open up. I want everybody looking at this same thing at the same time as we're going through it. Well, you have to sit next to him. All right. What's that? Oh, it's just it's just using diagrams. Think of 2-4 as diagrams. It also talks a whole lot about different postulates and things like that. I am not going to label through everything. That's a pain in the butt. There's no reason. Because you can look at diagrams and everything. Excuse me. So if you don't have your Chromebook, make sure you sit next to somebody that does. And that way we can work through and look at this same example together. Now, on the website, you're going to find this. Diagrams and postulates. Oh, snap. Something went wrong. Let me open this up.
Scroll down.
And I'll show you guys where to find this again.
Is it in chapter 2?
I would be chapter 2. It's good guess. Chapter 2,
Would it be in chapter 2, section 2.4?
I'm looking at 2.4 practice B.
Oh.
Okay? I want to look at the 2.4 practice B worksheet and just scroll to the second page.
This one.
Yeah,
What the second page?
just scroll.
Scroll down, Brandon.
Scroll down,
It's not loaded.
click on it.
It's still not loaded.
Oh.
Thanks. All right. Everybody get this okay? So what I want to do is we're going to look at this diagram to determine whether or not things are true or false. And we know certain rules about, bless you, we know certain rules and stuff about points, lines, planes, and stuff like that from back in chapter 1. So what I want to do is kind of walk you through what the book tends to do in terms of how things can be assumed via a diagram. And that's the kind of thing that we are going to be able to do more and more of throughout the school year. You have to be able to look at a diagram and take specific information from it in order to do problems, more so later on. Okay. But for right now, we need to use definitions and look at things to identify whether or not things are going to be true or false. Things that you can say. So we look at the first one. It says points A, B, D, and J are coplanar. So our points A, B, D, and J, are those guys all on the same plane?
Yes.
Yes. So therefore that would be true. You get the idea? That would be a true statement. Angle, EBA. Yes, sir.
You want us to write down those answers?
You don't have to write them down because it's kind of tough because you can't write on your Chromebook.
Well, like on a piece of paper.
If you'd like, but remember what I'm doing here is that way you get the idea of what are you going to be able to assume versus what can you not go for on the diagram. That's kind of what we're looking at here.
All right. Angles E.
Is angle EBA, can we assume that that's going to be a right angle?
Yes.
No, why can't we say that?
Oh.
Does it have what?
This.
There's no box. Exactly. Remember, whenever we have a right angle in a diagram, what will they always show you?
We'll show you
That little square. Do you see one?
No.
So can you assume it's a right angle? No. That's the kind of things you can do. Okay. You will be surprised the amount of times that you guys will make stuff up from a diagram. You can't make stuff up from a diagram, guys. You can't just say, oh, it says so. Points E, G, and A are collinear. E, G, and A. Why not? They're not even on the same plane. Very good. They're not on the same plane. Okay. What is that? Is that a segment or a ray? I couldn't see. It's a. Is that a ray? Yeah. Ray FG is ray FG in perpendicular to plane H.
No.
It's false.
No.
No, it's true.
Oh, wait, no.
It's false.
Which is it?
Both.
Why?
Both.
So
So
you
you
be right.
Yeah, right.
If you look at it closely. Why is it false? First of all, if it's perpendicular, what would be created? Do you see a right angle? No. Also, is it line? I think it's line FG. I can't really see. Is it line FG? Yeah, it's line. Isn't FG just in the plane H?
No.
Yes.
Yeah. It's if it was perpendicular to it, it would have been coming through a different plane. What it looks like to me here is that it's in that plane itself. It's just lying in that plane. It's just a line in the plane. It doesn't say that it's perpendicular. It looks like it's lying in it because it's coming through. A lot of times when you see diagrams, this little dot, 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 that means it's behind something. What this diagram is
It's basically.
it's just this. It's too long. These, I don't rip your papers. That's all it is. It's just.
This, we were talking about how you could bring DJ at the homecoming dance, and you'd probably be the best DJ. Hey, Logan.
Oh,
You see
well.
those Spanish girls?
It's all this is this picture, guys.
At homecoming?
That's it. That's all this is. And that line is one of these blue lines here on that plane. It's not perpendicular, it just lies within that plane. Okay. Angles ABD and angles EBC are vertical angles. Angle ABD right here and angle EBC right here are vertical angles. Well, to me,
You should have went to the
Huh?
game. I tried to tell you.
is that, let's see, if it's going across the crease here,
Next holiday, you listen.
now that's the angle of the crease that's formed on that plane. Oh, would you say those are vertical then?
Yes.
Yeah. You have to look at that one carefully though, because when I'm looking at this, I wanted to make sure that this line, ED, was on the plane K. Because this crease here, this line AC, is where the two planes intersected. It's kind of like the idea of the ceiling hitting the wall. Okay? It's that crease line where they intersect one another. Well, speak of the devil. Planes H and K intersect at line AB, yes or no? Okay, just line FG and DE intersect. Do FG and DE intersect one another?
Yes.
No. No. They don't. They're in opposite planes, and they're not going to intersect one another. What are those called then? Two lines that don't intersect that are not in the same plane. No. Starts with an S and ends in
Ends with
a
a
Q.
Q.
Skew. They're called skew lines. We had that definition last chapter.
You did?
Excuse me, Dr.
No, he
No.
made that. You made that angle up.
No, did not make that up. I'm sorry.
Say sorry.
Okay. That was in one.
Sorry.
And then lastly, angles GCA and angles CBD are congruent. GC, angle GCA, and angles CBD are congruent. Is there any way of knowing that those two angles are congruent? No.
Because it's not.
Well, they're not even intersecting one another. They're completely two different angles. If we had tick marks on them, then you could say it. Now, we did have vertical angles here when we had these guys. If they said that those two angles were congruent, what would you say?
True.
Because they were vertical. So when you have vertical angles, you are going to be able to say that they are congruent. Right? Now, the other part on this one I want you guys to take a look at is, can you build your own diagram? So this is the one I want to look at.
Impossible.
Sorry.
Mr. Gray,
Yes, sir.
I believe you screw up somewhere.
I want to walk through this one. This one you're going to want to draw out. A friend emailed you the following statements about a neighborhood. It's on your thing here too. I was
Mr. Gray.
okay.
Oh my
Use the statements to draw the map to answer the questions. Now, hold on. Hold on. One of the things you first have to remember is directions. We need to make a key. We need to label north, south, east, and west. Do you remember how that goes?
Yeah. Let's first draw a compass.
That's right. Let's draw the compass.
North.
What's
At the very top is going to be north.
north is up top, okay?
East is to the right.
Yes.
South is the bottom, west is to the right.
Never eat soggy waffles.
Wow.
Actually, I completely forgot that.
Okay, never eat soggy waffles. So, we start with the first one here. Building B is due south. You know what due south means? Straight directly south. Very good. So, if I want to start drawing this out, I know that A would be here, B is here. Building B is due south. We okay with that? A and B are on street 1. So this is street 1. They're on street number 1. Building C is due east of building B. So where would C be placed?
Right.
Right.
Oh,
What's our compass say?
down.
Goes to the right, so building C is over here. And these two guys are on street number 2. Are we okay with that?
Yeah.
All right. Building D is southeast of building B. Now, if you're southeast, what way are you going?
Down and right.
Down and right. So
Towards Florida.
towards Florida. Yes, exactly. We're going towards Florida. Southeast is on an angle between south and east. Okay. Usually, when they say southeast, you want to just think of it as like a halfway, about 45 degrees between it's about halfway between the two. Okay? That's generally what we look at. So I'll put building D. Excuse me. And then it said that these two guys are on street what? Street 3. And building E is due west of building C. Okay. Building E is due west of building C. So it's got to be to the left or to the right of, does it, we don't know. It's going to be somewhere on street 2. So it could be here or it could be here. We're not sure yet because the last statement says that angle DBE formed by streets 2 and 3 is an acute angle. So, go ahead. No, go ahead. Pass, go ahead. No, please. Why?
It goes to the left, it'll make an option.
Right. Everybody understand that?
Yeah.
It said that it had, this last statement says it has to, this angle here has to be acute.
So B is between B and C.
Exactly. Because because we had 2 different places for it to be, because it says due west, so it's got to be to the left of it. Since that last statement tells you that this angle formed is acute, that means it has to be here. Okay? And that's how that works.
So that's the town.
There's your town, and then you can answer questions. Okay? Okay. Sorry, go ahead. So, yeah, we'll do stuff like this. I got a couple of things like this, and I got the law of detachment and syllogism to look at as well. So if I look at the diagram here, let's read the questions, and we'll go off our diagram.
Oh, yeah.
As you guys are reading what you have, we can look at these. Hey, draw a diagram of the neighborhood. Done. Where do streets 1 and 2 intersect? At B. Very good. They intersect at building B. What kind of angle is formed by streets 1 and 2? Correct. Now, most streets, when city planners set this stuff up, you guys realize that most streets are parallel to one another, and then they have the perpendiculars going between. That's how most street grids were made up. All right, if you look at Chicago, that's how it all is. Even still, even in DeKalb, not so much, I don't think, in the neighborhoods out in this area yet. No, but when you get in towards town and stuff like that, most towns, even small towns, they have the grid system. I mean, if you go through Malta, that little part of Malta right there, everything's perpendicular. All the roads are perpendicular to one another. You know, you get into like neighborhoods though, a lot of neighborhoods have the winding curves because it looks fancier, the subdivisions, but most regular towns, everything is all done via grid.
Has anyone been to Washington DC?
Nope.
If you know your alphabet and you know how to count, you can find your way in DC, because the streets go B, C, D, E. If I had to be at M and 34th Street, and if I was on
You get lost.
C, all I need, I have to look which direction the alphabet's going. Maybe there's B, there's, okay, I'm gonna go this way until I get to M. And if I'm on 32nd Street, I just have to look at my numbers, the 34th is that way, go that way.
New York's like that too. New York City's all numbered streets. Everything's numbered streets, and then to get around, you know whether you're going up or down, just by via the numbers. So,
I'll get lost.
no, you won't. As long as you can count, you're gonna be okay. What street was building E on in this case? Two. And then is building E between B and C? And why did that happen? Because of the acute angle, because it's lit. Alright. Let me give you guys some problems. We got done a little bit quicker today than I did, which is fine.
Hey, look at this.
Yep. The problems I have for us, I have not put it on the calendar yet, because I'm still working on figure out the exact ones. What I'd like you to do is in section 2.3, this is in the book.
This is our homework.
What's that? Yeah. So the 2.3 is on page 90. I'd like you to do numbers 4 through 9. And then on section 2.4, which is page 100, numbers 14 through 23 and 39. Okay? And I'll show you guys here in a second what those 4 through 9 look like, so that way you get the idea, because those are going to be going through like the law of detachment, law of syllogism, to tell whether or not things are valid or whatnot, okay? So let me pull that up real quick and walk you through it.
If you don't have a Chromebook, there's some textbooks in the cabinet that you can borrow.
Numbers what? Mr. Murphy, right before I could write it down, you switch it.
14 through 23 and 39.
And page 2.4,
That's page 100.
100,
Yeah.
90, 44, 94,
Well,
34.
let me. If you give me a second, I don't have everything on the calendar. You guys can look at it. Okay.
Are you gonna pass back the test?
Yeah.
You said we did pretty good.
Yeah, you guys.
Right here, guys.
What's up?
Hey, you have some products named after you, like Murphy's Oil, you know, hardwood floors. Famous.
I'm famous. I'm something, right? So let me show you this, guys. When we're looking at the law of detachment versus law of syllogism, how do you make a valid conclusion? So if I'm looking at number 4, it states here, using the law of detachment, make a valid conclusion from the given statement. If the measure of an angle is 90 degrees, then it is a right angle. The measure of angle A is 90 degrees. So what can you say? Angle A is a right angle. That's it. That's all it means. That's all that means. I just gotta sign it out too. Okay. That's what you're looking at. That's how detachment works. If I look at syllogism, if a rectangle has 4 equal side lengths, then it is a square. If a polygon is a square, then it is a regular polygon. So what can you say? Well, if a rectangle has 4 equal sides, then it is a regular polygon.
Do I see the repetition there?
If a rectangle has 4 equal sides, then it's a square. Polygon is a square, then it's a regular polygon.
There's the diagonal.
So there's your diagonal, the square part's repeated. So then what you can say, if a rectangle has 4 equal side lengths, and there's a regular polygon. That's all it is, okay? So go ahead and get started on those. Should not take very long to go through those, and we'll see how we do. Tomorrow we'll start going through our list of properties for some algebra stuff, and then that way we can start working algebra. We do have calculators in again, so if you guys still need to get a calculator,